So next we have Ryan Amesbury from Dassault Systems. Dassault is providing GoAERO teams with access to free and discounted software, including SolidWorks and the CATIA for 3D design, Simulia for structural simulation, CFD, electromagnetic simulation, Delmia for manufacturing, Innovia for project lifecycle management, and the 3D Experience platform. So Ryan will be able to share more information on everything that they've made available to the teams. Ryan, thanks so much.
Thank you. Hey everyone, my name's Ryan. I work at Dassault Systems, and as you probably heard, we have a lot of different tools that are used by aerospace companies. I'm sure many of you are familiar with SolidWorks and CATIA, which are two of the most popular CAD tools in the world. So we'll jump into things here. Just wanted to start with some of the companies that use our products to develop their aircraft. So many of the largest OEMs in the world design their aircraft. On this slide, they're mostly fixed wing, so Boeing, Airbus, Embraer, Dassault, which is actually how the company started about 40 years ago. It was a homegrown CAD tool to design fighter jets, which is pretty cool. And then a lot of the big vertical takeoff and landing companies use our products too. So like Bell, and then many of the startups that you see here, including Vertical, Beta, Whisk, which is part of Boeing. So lots and lots of experience over the years working with a really wide range of aircraft manufacturers. And our team has really packaged our vast array of tools into some easy to start with options for startups, which we refer to as Reinvent the Sky, which you saw on the last page there. So you can get all the way from your initial conceptual design all the way through certification and into production with our tool set. On this next slide, we'll take a little bit of a look at kind of a high-level overview of what a design process looks like from initial conceptual design through design and simulation and into manufacturing and ultimately operating the aircraft and doing things like predictive maintenance. So I think really where we're wanting to focus with the GoAERO teams is on that early conceptual design into the full design for production and simulation. And something that's really beneficial with simulation is you're able to simulate your eVTOLs on a computer. So you're not having to build the entire aircraft, test it, potentially crash it, have lots of hardware costs. While simulation on a computer isn't 100% the same as in reality, you can get really close and iterate a lot faster and improve your aircraft. So these are just a few of the different tools that we have to offer from the conceptual through design and certification. On the left side, you can see some of our concept and systems modeling simulation tools, concept synthesis, which can have a wide variety of different inputs into that, such as figuring out the weight, the flight range, even FAA certification criteria. Going into design, there's lots of options for testing and iterating on different versions of your aircraft to find which one ultimately is the best option for you. And then you can get into some more advanced design like battery pack simulation, composites design, and even computational fluid dynamics to see how the airflow interacts with your aircraft and overall performance. And then later on, into certification, which is important prior to commercialization, and ultimately getting into production with our Delmia line of products. All of that's tied together at the bottom here. You can see the continuous digital thread, which is very important for FAA certification. Now we'll just jump a little bit into some of our different tools and different options within the wide variety of tools that we do offer. So this is an example of iterating on different versions of your aircraft, and you can test and simulate different configurations, maybe where you want your rotors, if you want to have fixed or variable pitch propellers, lots of different options there. Jumping a little bit more into the different configurations, you can also put in those different design criteria, and then as you can see kind of in the left Top left corner, see how each of the different options compare in a wide variety of different areas, like range, the amount of weight they can carry, which are both quite important for this competition. This is an example of some of the CFD work you can do, so you can really simulate how your aircraft interacts with the air. Also test different densities of air, which is of course dependent on temperature and elevation. And also for simulation, you can do structural simulation too to get an understanding of how strong your aircraft needs to be to carry a load. There's lots and lots of different types of testing you can do within this. Some of the other cool tools that we have are our composites design. So you can model your composite layup prior to production. So that's helpful, obviously, if you're trying to reduce weight. Composites like carbon fiber are a great way to have a strong aircraft while not having a lot of weight. Some other cool tools are generative shape design. So this is an AI-enabled tool that you're able to put in different inputs and then optimize for a wide variety of different criteria. In the top right, you can see kind of a traditional design that someone might have done themselves. And then on the left, there's a few of the different generative shape design models where you're able to lightweight that component while maintaining the strength and rigidity and any other factors that are important to you. And then that pairs very well with 3D printing. Some other cool tools are wire harness design. As you can see, this is one of our example eVTOLs that has propellers hidden within part of the aircraft for cruise, and then they pop out for takeoff and landing. So you can get high fidelity renderings and do your wire harness design within CATIA as well. Here's another example that's really helpful prior to testing your aircraft, is really making sure that your weight and balance is thoroughly calculated. So you don't try to flight test for the first time and have your aircraft roll over or crash from some other issue that wasn't taken into account prior to actually flying it. So I know that was a lot of different tools. We sort of bucket those into really three main different areas here, which are the collaboration piece. So your team is able to have specialties in these different areas. If you're spread across locations, you're able to collaborate in real time. The design part, which we saw, simulation, and then there's some other tools for manufacturing as well as information intelligence.